All right, so what I want to do is talk to you about a simple series circuit. So in a series circuit, like I said in my lecture videos, is that you have resistors that are actually tied to each other. So basically they go in a circle. So if we look at this one, we have a positive rail. This is the positive rail up here. Here's a negative rail. These are independent of each other. Here's another negative rail and another positive rail right below it. Again, independent up here. So I have my negative lead down here and my positive lead over here. See that? There's my positive, there's my negative. So what I want to do now is I'm going to bring this in just a little bit closer. And I'm going to show you that how to connect this up. Let it focus itself. There we go. So basically what we have here is I take in one lead and put it to the positive and another lead to one of these holes. So I basically have it to this hole. It's number 15. And if you go look at this, instead of going across, they're actually connected vertically instead of horizontally. So all this isn't connected together, but it's independent here. So call this the Grand Canyon. So basically I have one wire, one resistor, a 100 ohm resistor. That's brown, black, brown. That goes from here back to here. And then I have my 210 ohm resistor that goes from the same hole here back to another hole down here. And then I connected up my last resistor, which is 380 ohm resistor. And it goes back to the negative. So now if I actually want to, I can actually measure the values. So remember I told you in the lecture, that the lecture videos, that we measure voltage. We measure the voltage drop of a resistor in parallel. So if I take my meter, and I connect up the leads, and I take one lead and I put it to one side and I take another side, I should get voltage, and I do. And I get about 0.7 volts. You see how I'm connecting it up. Again, I do the same thing for over here, and I get a voltage 1.92. And my last one should be the largest voltage reading, and that should be the ground. And that's 2.74, which does make sense because we are actually we actually are going in series with each other. So the voltages across each one of these resistors is going to be dependent upon the size of the resistor. So if we have a high resistance, that means it's going to drop the most voltage, and the smallest resistor is going to drop the smallest amount of voltage. So now what we want to do is we want to measure the current in this circuit here. And like I said, when we're measuring current, we actually physically have to physically disconnect one of the leads, one of the wires. In this case, what we're going to do is disconnect one of the resistors. So I'm going to show you how to measure total current, and let's see if I can get this meter to be right in here. Let's see if we can do that. And let's bring this out just a little bit more. Best I could do right there. So what I'm going to do is I'm going to show you that how to connect up the meter. So basically what I did is I have one lead, the red lead, to amps, and the other lead to common, and then my knob, I'll bring this out just a little, whoa, wrong way, there we go. Now I'm going to turn my dial indicator to the highest setting. I usually start around 200 mils, and then I can bring it up or bring it down. Most people say bring it to 2 amps, and you start, but we're working with this circuit, so I bring it to 200 mils. So I bring it to 200 mils, and then what I'm going to do, that's much better. And then what I'm going to do now is I'm going to take my leads. Well, I told you we have to break the circuit. So I total is basically coming off of the power, the plus on here. So what we're going to do is break it. So I just broke it right there. So if I break the circuit right there, I got to repatch the circuit. So to repatch it, I have to take a wire, another wire, and I'm going to connect up my red to that spare wire, and I'm going to connect it up right there. I'm going to take this other lead and connect it up to where I broke it at. And I get my meter, I get reading 7.7 mils. So if I keep bringing this down, it gives me more accuracy, 7.65 mils. And I can't bring it down any further than that, so that's about the best I can do. So that's how you find I total. So I total is 7.67. Well, in a series circuit, we know that current's the same. So what I'm going to do is remove this guy and remove this guy. And I'm going to prove to you that current's the same. So I'm going to go ahead and just break it right in the middle here. Now I don't need my wire anymore. So I can connect up my positive to close to the positive. It's a little tight in here, folks. There we go. And then I'm going to take my other lead and bring it right there. Now I get, there it is, 7.7 mils. So the current is the same throughout the circuit. If you have any questions on how to actually read current, or to measure current and to measure voltage, please come and see me.